Deep learning versus machine learning. AI. Machine learning. Deep learning. If you spend 5 minutes reading tech news, you're going to hit these 3 buzzwords. People use them interchangeably all the time. But here's the secret. They are not the same thing. If you've ever wondered why your email spam filter is pretty good, but ChatGPT is mind-blowing, you need to understand the difference between these terms. Today, in just 5 minutes, we're going to break down exactly what separates machine learning from deep learning without needing a PhD in math. Let's go. First, we need to establish the relationship. Think of it like Russian nesting dolls. The biggest doll is artificial intelligence. That's just the broad goal of computers doing smart things. Opening that up, the middle doll is machine learning. And inside that is the smallest, most complex doll, deep learning. Machine learning is a subset of AI where computers learn from data without being explicitly programmed for every single task. Deep learning is a specialized subset of machine learning inspired by the human brain. So, all deep learning is machine learning, but not all machine learning is deep learning. Got it? Good. Before we continue, please subscribe to my channel at Everything AI 2026. Click the like button and share the video. By subscribing, you gain access to a dedicated knowledge hub designed to keep you at the frontier of the AI revolution. We don't just report on the news, we decode the future. Now let us continue. Let's start with traditional machine learning. It's been around for decades and it's incredibly useful. Think of ML algorithms like master statisticians. They are great at finding patterns in structured data, things you'd find in an Excel spreadsheet, like sales figures or customer ages. But here is the defining characteristic of traditional ML. It usually requires human intervention. This process is called feature extraction. Let's say you want an ML algorithm to tell the difference between a picture of a car and a motorcycle. A human expert first has to tell the computer what to look for. You have to define the features, like count the wheels, or look for a steering wheel versus handlebars. Once you, the human, define those features, the machine learning algorithm is fantastic at crunching the numbers to make predictions. But if you don't tell it how to distinguish them, it fails. Now, what if we want the computer to figure out what to look for on its own? Enter deep learning. Deep learning tries to mimic the structure of the human brain using something called artificial neural networks. The magic word here is deep. It refers to the many, many layers in these networks. Unlike traditional ML, you just feed raw data, like a whole image, into the neural network. The first layer might just detect brightness. The next layer detects edges. The middle layers start recognizing shapes like circles. The final layers put those shapes together to recognize wheels, and eventually, a car. The crucial difference? It did this automatically. Deep learning automates that feature extraction step that humans used to do. It teaches itself what is important in the data. So, why don't we use deep learning for everything? Because it comes at a cost. Deep learning is data hungry. An ML algorithm might learn to spot spam emails with a few thousand examples. A deep learning model like ChatGPT needs billions upon billions of data points. Deep learning also requires massive computational horsepower, usually expensive GPUs, and takes much longer to train. Traditional ML can often run on a standard laptop. To summarize, if you have structured data like tables and you know exactly what features matter, traditional machine learning is faster, cheaper, and easier to understand. If you have messy, unstructured data, like images, huge bodies of text or voice recordings, and tons of computing power, deep learning is the tool that can perform miracles. Thanks for watching. If this cleared up the confusion, hit that like button and subscribe for more tech explainers. See you next time.